Okay, this lesson is 8.7. We've got 2 more lessons left in the trimester, and today we're going to talk about systems of inequalities. So in Unit 7, the take-home unit, you learned how to graph linear inequalities. Well, now we're going to talk about what happens when we have 2 of those. So your aim today is that I can solve systems of inequalities using the graphing method combined with shading and the dotted and solid line rules we learned in Unit 7. We can have systems of inequalities as well as systems of equations. The definition of solving a system still holds. We have to find all the points that make the inequalities true. So exercise 1 is going to walk us through this process. So number 1, consider the systems of inequalities shown below. They're actually not shown below, they're shown over here on the right. Okay? Determine if each of the following points is a solution or not to the system. So the first point is 3, 8, so that's an x and the 8 is a y. And to determine if something is a solution, I plug it in. So the first equation is x plus y is greater than 10. So I'm going to plug in 3 for x and 8 for y and see if this is true. 3 plus 8 is 11. Is 11 greater than 10? Yes, it is true. But you also have to see if it works for the second one. In order for this point to work, it has to work in both of these. So I'm going to try the second one. Y is greater than or equal to 3x minus 5. And I'm going to plug in x and y again. Y is 8. And x is 3. So I plugged in 8 and 3. And I'm going to see if it works. I have 8 on the left. 3 times 3 is 9. Carry down the 5. Is 8 greater than 9 minus 5, which is 4? Yes. So the point 8, 3, 8 works. So we know that that's a solution. But in a system of inequalities, we can have multiple solutions just like a system of equations. There isn't just one answer, it's all of the points that work. So let's try B. Let's try 5, 9, a new xy point, and see if this one works. Let me draw a line here to separate these two because they're two separate problems. So the first equation again is that same one. X plus y is greater than 10. Remember, I'm getting these from over here. I'm going to plug in the 5 and the 9. So x is 5 and y is 9. 5 plus 9 is 14. Is 14 greater than 10? Yes, so it works for the first equation. But we have to try the second one. So I'm going to write the second one out again. Y is greater than 3x minus 5. And I'm going to plug in x and y, 9 and 5. So the 9 goes in for y, and the 5 goes in for x. Let's simplify. 3 times 5 is 15, and 15 minus 5 is 10. Is 9 greater than or equal to 10? No. This is false, so this is not a point on the line. So one way I can just say that is I can say 3, 8 is a point, and the 5, 9 is not a point. Okay? Now, how do we actually figure out what all of the solutions are? Well, that's what we're going to work on in letter C. So, there are a couple steps. So, the step number 1 is to graph the inequalities. Okay, now oops, let me spell that right. Inequalities. Okay, so the first inequality, let's make that one purple. So here's the purple one. X plus y is greater than 10. I need this in y equals form, so I'm going to subtract the x on both sides. The x's cancel out, and I get y is greater than negative x plus 10. This gives me, there's an invisible negative 1 here. Now I can put this in my calculator, or I can remember that m is negative 1 over 1, and b is 10. Either way works. I also have to remember, because I'm working with a greater than sign, I'm going to have a dotted line. And I'm going to shade, because remember we have to shade when we have inequalities, I'm going to shade above this line, because it's greater than. So I'm going to go ahead and graph this. So b is 10, so I'm going to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my y-intercept. And then I'm going to do my slope, which is rise over run, which is right here. Negative 1 over 1. Because my slope is negative, I'm going to go down and to the right to make a negative line. So down 1 over 1. Like I said before, though, you can also use your calculator to graph this. and it would give you the table with all these points, and you just have to remember to make it dotted or solid. I need a dotted line, so I'm going to make a dotted line and then draw my arrows. I have to also remember that I'm working with greater than, so I have to do shading. So I'm going to just shade above this line. Okay? Now in a system of inequalities, I have to graph both of these. So I'm going to use green for my second equation. My second equation is y is greater than 3x minus 5. The nice thing about this equation, it's already in the right form. I already know that m is 3 over 1, and I know that b equals negative 5. You can put this in your calculator again, or we can do rise over run rules. So b is negative 5, so I count down to 5, which is right here. That's the y-intercept. And then I'm going to go up 3 over 1. And it's positive, so I'm going to go up and to the right. Up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And I'm making, oh, I messed up, sorry. I have to remember, I didn't mess up, but I forgot to write this down. Because I have this symbol right here, that means I have a solid line, because I have the little equals underneath it. And this is going to be also shaded above, because it's a greater than. So both of these we shade above. So I'm going to make my line. Okay, and then I'm going to shade. You shade everything above this line. Now, what's going to happen here? Do you see the part where the green and the purple overlap? I'm going to highlight this for you. So see this part here where this overlaps. I've got this dotted line here, and then this solid line, and then here. Okay, this little triangle, that triangle is the solution set, because that's where the colors overlap. So your second instruction is to find the solution set by seeing the overlap. Now this is hard. This is harder when you have pencil, because it can be kind of hard to see the overlap. I'm using colors, so it's a lot easier to see the green overlapping the purple. Okay, but this is your solution set. Alright, all of the points in here are solutions. So notice that if I go back to this point here, this 3, 8, we said that was a solution. Well, look where 3, 8 is. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. See how that point falls in the triangle we made? That's why it's a solution. But if I select the blue point, 5, 9, this right here, 1, 2, 3, 4, 5, and then up 9, this is not in the solution set. Okay? So, sorry, hold on. Let me retype this. Okay. Okay. Alright. Let's go on to the next exercise. Exercise 2. On the grid shown below, graph the solution to the system of inequalities. State a point, that's really important, that lies in the solution set, and state one that doesn't. So we're going to first solve this on the grid, and then name a point that's in the solution set and a point that's not in the solution set. If you want to try this on your own, please feel free. You can use your calculators. You can do this by rise over run. So the first thing I'm going to do, I'm going to make this the red equation. Remember, m in this equation is that number in front of the x, which is negative 3 over 2. That's my rise over run, and my b is 2. So for the red inequality, I'm going to start at 2, and I'm going to go up 3 and over 2 to the left because it's negative, and I want a negative line. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Now I have to ask myself, is this going to be a dotted or a solid line? Well, it has no equal sign under it, so this is going to be a dotted line. So I'm going to connect these with a dot with dashes, dots. Okay? And then I have to ask myself shading. This is a less than sign, so I'm going to shade below. So I'm going to shade the whole grid and everything below it. Okay? All right, that's the first equation. Now let's graph the second one. I'll use blue. Okay, so the blue equation is x is greater than or equal to -2. Now I remember from my unit 7 that when I have something with x, it's going to become a vertical line at -2. So I'm going to go to -2 on my x, which is right here, and it's all of these points where x is -2, right? All of these points have an x at -2. And now I say, okay, is this going to be solid or dotted? This will be a solid line because it has the equals to. So I'm going to connect it with a solid line here. And am I going to shade above or below? Now with a vertical line, you're really shading to the right or to the left. Well, if this is a greater than, I want all the numbers greater than 2. So all numbers bigger than -2, which means I have to shade to the right of this line. Okay, because these are all of the numbers greater than -2. Okay, now I've created my overlap. I'm going to highlight that in black, keeping a dotted line and the solid line. Keep in mind anything else below here, like down here, is also part of the solution set. We just can't see it on the grid. Okay, so now let's name a point that's in the solution set. There's a lot of them. I'm just going to pick a few. So here is one right here. That's at the point 1, 1, 2, 3, 4. So a point 1, -4. Here's another point right here at -1, -2. Okay, etc. You can think of a lot more points that can work on this. A point not in the solution set, and I want to be really clear about this, let's take a look at this point right here. That point hits the dotted line. A dotted line means that the point can't work. A dotted line means it cannot work. So this point actually, this 1, 0 right here, that's a point not in the solution set. And I'll make that a different color so we can see that better. Right? That's not in the solution set. Here's another point not in the solution set over here. 1, 2, 3, 4, 5, -1. It's in the solution set of the blue, but not the red. Over here is a point in the red, but not the blue. -1, 2, 3, 4, 5, -3. So these are all points that are not in the solution set. So it's really important to be able to determine what's a solution and what's not. You want that overlap shading. Okay? If you've forgotten the shading rules and want to write yourself a note, I'll put it on this exercise right here. If you have a greater than or equal to or less than or equal to, you'll have a solid line. If you have a less than or greater than, that is a dotted line. If you have a less than, equal to, or less than, you shade below. And if you have a greater than or equal to or greater than, you shade above. So if you want to write this down somewhere, it is from Unit 7, which was your take-home unit. I would put this down somewhere because you do have to memorize this. This is not something they will tell you on the Regents, so you need to memorize it. Okay? Alright, let's take a look at Exercise 3. Exercise 3 is a multiple choice question, so let's read. Which of the following points is a solution to the system of inequalities shown below? Show the work that leads to your answer. Now there are several ways we can do this. You can graph this. Unfortunately on this problem, it does not offer you a grid. So what I'm going to do instead, and if I were smart, which I am, but I don't have the resource here, I would use graphing paper and graph both of these. But let's pretend we don't have graphing paper. Our options are to plug in all of these XY pairs and see which one works. So I want you to pause the video right now and try that. Plug these pairs into your systems and see which one works. Okay? When you unpause, I'm going to come back and you'll see all of the work that leads up to that. Okay? Pause now, please. Okay, answer choice number 1 is I'm going to rewrite these two equations and plug in my x and y. So y here is -6 and x is 3. For some reason my pen disabled. Alright, -6 stays, but I'm going to simplify the right and get -12. Is -6 less than -10? Yes, it is. So that one works. Let's try the next one. -6 is greater than 3/2 plus 7. Even if you didn't have a calculator, -6 is definitely not bigger than 7 plus 3/2. -6 is a negative number, and it's got to be less. So this is false, so it can't be answer choice number 1. Okay, let's try answer choice number 2. I'm going to rewrite the equations again. Y is less than -4x plus 2, and y is greater than x plus 2 plus 7. If you already did all this work and want to fast forward the video, it's fine with me. I'm just going to show it out for students that want to see all of the work. I have no problem with you fast forwarding through the work if you know what to do. So this next one is x is 0, y is 2. So I'm going to plug in 2 for y and 0 for x and simplify. -4 times 0 is 0. 0 plus 2 is 2. Is 2 less than or equal to 2? Absolutely, it's true. Let's see if the other one's true. Plug in 2 for y and 0 in for x. 2 is greater than 0 divided by 2 is 0. And 0 plus 7 is 7. Is 2 greater than 7? No, that's false, so that one can't be true. Let's try number 3. Number 3, x is -2 and y is 10. So I'm going to rewrite my equations again. -4x plus 2 and y is greater than x over 2 plus 7. And I'm going to plug them in again. So you can see right now how graphing these two things might be a lot easier than doing this guess and check method that we're trying to do. This is taking a lot of time. But graphing in the previous exercise, we could see all of the solutions instantly. So the point of this exercise is to see how much more efficient it is to graph them. So I'm simplifying this. I end up getting 10 less than or equal to 10. That is true. And on the other one, I get 10 is greater than 1 plus 7, and that is also true, so it looks like I've found my answer in number 3. Okay? I'm going to assume number 4 doesn't work, but if you want to check, please feel free. Okay? Alright. Let's see. Last exercise, I think. Oops, sorry. Alright, the last exercise is exercise 4. Okay, in exercise 4, we're just going to start off very simply. Consider the system inequalities given below. So here's the system. It's very big. It's actually 3 equations instead of 2, which is okay. A system can have more than one equation. So we're going to end up graphing all 3 of these onto the grid. So part A says, first of all, determine which of these points is a solution to the system. Excuse me, if any of them. So I've got to plug in this x and y into all of these. So number 1, y is greater than or equal to -2. Is 4 greater than or equal to -2? Yes, so it's true for number 1. In fact, I'm going to color code these already. So there's the first one. Is it true for 3 and 1? Well, let's plug in 1. Is 1 greater than or equal to -2? Sorry. It is, so for both of them, the first equation works. Let's try the second equation, which is x is less than 4. So x less than 4, x is -1. Is that true? Yep, -1 is less than 4. Let's try it for the second equation. X is less than 4, and here x is 3, so it works for the second one as well. So far we've got both these points working. And let's try the last one. Y is less than or equal to 2x. Here y is 4, and 2 is -1. Is 4 less than or equal to -2? No. So it doesn't. So this is not a solution because it doesn't work for the third one. Let's try the second one. Y is less than or equal to 2x. Y is 1, and x is 3. Is 1 less than 6? Yes. So the second point works, but the first point does not. Okay? So I'm going to write this in red. No. And yes. Okay? Alright, letter B now says sketch the solution on the grid. So we have to sketch each of these graphs. So the first one I'm going to sketch is the y is greater than -2. So remember, for y is greater than -2, this is a horizontal line. Actually, let's write this somewhere else. So y is greater than or equal to -2 is a horizontal line at -2, and I want a solid line, and I'm going to shade above because it's a greater than. So I'm going to go to -2 on the y-axis, which is right here, and I'm going to make my points all at y is greater than -2. So here are all my points, and I need to make a solid line. So here's my solid line, and I need to shade above. So here is me shading above. Alright, that's the first one. The second one is blue. So let me find some space here to do the blue one. So the blue equation is x is less than or 4. So x is less than 4 is going to be a vertical line at 4. I'm going to have a dotted line, and I'm going to shade to the left because this is a vertical line. So I'm going to go to 4, x at 4, so 1, 2, 3, 4. So here's the 4. It's always x is 4, so I'm going to make points all along the 4. And I'm going to connect it with dots. And I'm going to shade to the left because it's less than. Okay. Now the third equation is my green equation. And I'm going to put it right here. Y is less than or equal to 2x. This is going to have a y-intercept at 0. Okay, and a slope of 2 over 1. I need this to be a solid line, and I'm going to shade below it. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I'm going to make more points down here and go down 2 over 1. So I make sure I'm filling out my whole grid. And I'm going to make a solid line here through it. And I'm going to shade below. Okay? Alright, now in your paper this might look kind of crazy because you're using a pencil. Okay, so the next question says find the area. So find the area of the portion of the xy plane that represents the solution. So I'm going to highlight the shape that I've created with all of my lines. So it's a triangle. So I need to find the area of this triangle. So area of a triangle is 1/2 base times height. Now, how are we going to find our base and our height? Well, my base is this right here, and this is my height. Now I'm going to count how many I have. I have 1, 2, 3, 4, 5. So my base equals 5. And my height, I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My height equals 10, and now I can just plug this into the formula. 1/2 times 5 times 10. So I get an area of 1/2 times 50, and my area is 25. Okay? And finally, I know this video is one of the longer ones we've done, but it's a pretty tough lesson, so bear with me. The last question says, why does the dashed line of one of the borders not make a difference in terms of the area you found in part C? Well, area is a measurement of the space inside. So area measures space inside an object. Okay? Well, inside a two-dimensional figure. Right? It represents the area inside. It does not really, if we exclude a border, it doesn't change how many square units we can fit inside the object, right? If I'm talking about a solution, of course the dotted line doesn't count. But if I want to take care of what's inside, the dotted line does not affect area. Okay, and I've seen these kind of questions on the Regents before. They ask you to find area of the space. So this is a really good exercise. So I hope you made it to the end of this video. It's really important. And like I said, if you have questions, please ask me. Okay? And thank you for working through this really long lesson. I appreciate it. You're one lesson away from ending the trimester. Good luck on your fluency.